Alright, y'all, let's really quickly go over the do now. I'm going to go over this because it's important for you to know for your assessment in this unit, and you're going to have to be able to do it very quickly. So here we go. It says to factor, and normally when we factor, we use the box. So I'm going to draw the box, and this is how quick we need to be able to factor. We want to multiply to a times c, so 3 times -2, which is -6. Again, that's a times c. We want to add to b, so add up to 5, which is b. All right, and we need numbers that multiply to -6 and add up to 5. So we should think of numbers. One way to do that is to like make a little table and think about what can multiply to 6. So we could do 3 and 2. We could do 6 and 1. Okay, and then let's think about what can combine to make 5 and make -6. So +5 is what we need to add to, and -6 is what we need to multiply to. That has to be this one, 6 and -1. So we're going to take those numbers, put them in the corner of our box, and throw an X on them. You can switch these ones, the 6 and the -1. If you want, you can switch them. But we definitely need 3x squared. The first term always goes in that box. The -2, the last term, will always go in this box. Okay, cool. Now we're going to pull out a GCF. So if we're looking on this line, this line has 3 in common. Oops, you could divide both numbers by 3, and they also both have x. And then this line, they both have negatives, and 1 goes into both of these numbers. Okay, cool. So now let's think about going up this line. Oh, man. And okay, I don't know why things keep disappearing, but let's pretend that didn't happen. 1 can go into both 3 and 1, so we don't care about that one, and they both have x. And then if we go up on this line, 2 can divide both into 2 and 6, and they do not both have x, so those are our factors. So let's go ahead and now make sure you know how to do this. You're going to write your factors, 3x minus 1, off of the box, x plus 2. Okay, cool. So now that we've written those factors, we have done this. Check, we have factored. Now we need to solve. Solve means find the zeros. That means find what x equals. So x equals, I'm going to use the trick. We need to be fast at solving. Flip the sign, +1, over, divide by whatever's touching x, 3. And x equals, flip the sign, -2. And we are done. Okay, moving on. Going to the next problem. Factor the following and solve. So same instructions. Cool. We are not going to use the box on this one because we should notice something special. We can take the square root. We can take the square root of both of these. So square root of x squared. We're going to use difference of squares. Difference of squares. Square root of x squared is x minus square root of 25 is 5. X minus 5. And then you have to copy that factor, but switch the sign. So difference of squares, you're always going to get two factors that match, but have different signs. Someone asked, does it matter if I put the minus factor first or the plus factor first? It does not matter. This operation is multiplication, so it doesn't matter which order you put these two factors next to each other. Okay, cool. Let's solve now. So we need to solve still. X equals, flip the sign, 5, comma. I'm putting a comma instead of writing x equals again, because that's okay. -5. Sweet. Done. Let's do this next one. Same thing. We can square root 36. We can square root x squared. We can square root 9. So we're going to use a square root trick, the difference of squares trick. Square root of 36 is 6. Square root of x squared is x. Square root of 9 is 3. And then I like to think of it as bring down the minus sign. Then again, with difference of squares, you are going to copy that factor. So 6x, but flip the sign, +3. And let's solve. X equals, flip the sign, +3, over, divide by whatever's touching x, 6. And x equals -3 divided by 6. All right, Now we can simplify. So let's simplify these. X equals plus or minus 3 divided by 6 is 1/2. Now, really quick, I forgot to do an important step. You're always supposed to check for something first. What are you supposed to check for first when you're factoring? GCF, greatest common factor. Really quick, let's look at what happens when you check for GCF first. It's important. Okay, so what goes into 36 and 9? 3. So 3 goes into 36 9 times minus 3. Okay, and then, oh, sorry, GCF is 9. Y'all, ooh, I almost messed that up. GCF is 9. 9 goes into 36 3 times. 4 times, I'm crazy. X squared minus 1. There we go. Okay, so if we do this, we should still get the same solutions. So let's go ahead and factor this even more. We can factor this using difference of squares. You get 9. Square root of 4 is 2. Square root of x squared is x. Square root of 1 is 1. And then we get 2x plus 1 because you have to flip the sign and copy the factor. Check it out, y'all. We get the same solution. Positive 1/2 comes from this factor. X equals positive 1/2 because we flip the sign, divide by 2. And then, oops, negative 1/2 comes from this factor because you flip the sign, divide by 2. So always remember to do a GCF first. That was my bad for not remembering to do that. The greatest number that went into 36 and 9 was 9. That's why I pulled out the 9. Okay, sweet. Let's move on to notes. So today we have a decent amount of notes. It may be a little difficult to take notes today just because normally I would print this off, but I want to remind you, you have this in your OneNote. So you can pull this up in your OneNote anytime. You could even pull it up as we're going through notes right now, and you could follow along with us. So really quick, in your notebooks, definitely make sure that you put the title, key features of quadratics, and graphing quadratics from factored form. You're still going to need to write notes down. Key features of quadratics and graphing from factored form. Okay, cool. And then the first thing I want you to do is actually sketch this graph in your notebook. So like, we're not going to draw the whole thing. We're going to draw important things that we see really quick. So you're going to sketch this in your notebook very quickly. Just copy the graph. Doesn't have to be perfect. Do you see how rough I'm doing it? Okay, and we're going to put something important. One important thing is this point. That happens at -3. And then another important thing is this point. That happens at 1. And then another important thing is this point. That happens at -3. Make sure you label your x and y axis. So this is y. That's x. Okay, cool. So now that you have this rough sketch, you should have this rough sketch in your graph. We can answer these questions. So go ahead and write down x-intercepts. X-intercepts. Okay, x-intercepts, you need to know x-intercepts is where you cross the x-axis and y equals 0. That's always going to be true for x-intercepts. So make sure you write that down. Zoom in a little bit for y'all. X-intercepts are where you cross the x-axis and where y equals 0. Okay, cool. So our x-intercepts for this graph, where we cross the x-axis, that happens right here. And we're going to write the points. They are points. If you want, you can write a note. Points. So we're going to write -3, x equals -3, comma 0, and, this is a little and symbol, x equals 1, comma 0, because this is where we cross the x-axis at those 2 points. Those are our x-intercepts. Okay, let's keep going. Factors. All right, this is really important. Factors use x's, use x-ints, and flip the sign. So to find the factors, you should use the x-intercepts right here and flip the sign. Factors have parentheses. So let's make sure we remember. You could draw like a little squiggly inside parentheses. Factors have parentheses. Okay, so for our factors, we have x plus 3, because I'm flipping the sign, and x minus 1. Sweet. Those are factors. All right, let's keep going. Y-intercepts. Make a note. Y-intercepts cross the y-axis. And we're going to have to write quickly, cross the y-axis, and x equals 0. So do you see how for x-intercepts, y equals 0, so it flips, and then for y-intercepts, x equals 0. Think of it as flipping. Okay, cool. So let's go to where x equals 0, that's right here, and this is where we cross the y-axis at the point 0, -3. So let's write that down for our y-intercepts. The point, it's a point, 0, -3. Again, x equals 0 for y-intercepts, y equals 0 for x-intercepts. It flips. Oops. Okay. Let's go back to where we were. Vertex. Vertex is where your graph turns around. So where you turn around. And I'll show you what I mean. Okay, this is a graph of a quadratic. Quadratics are shaped like U's. So where you turn around is your vertex. This point right here is our vertex. That also happens to be our y-intercept. Oh, wait. Sorry, y'all. This graph's a little different. I drew it bad. That's okay. Let's go off of the graph that we drew, because y'all have that in your notes. So let's say that the vertex is at the point 0, -3. For this case, we're going to put 0, -3. Then I'm going to say for our graph. But this is the vertex for this graph. So I'll just label that just in case you look back at the notes. And that is -1, -4 is where that happens for that graph. Okay, let's keep going. Minimum. Minimum, we're just going to say that is the lowest point on the graph. So let's write that. Lowest point on graph. And for an upward facing quadratic, so this quadratic is pointing up, right? For an upward pointing quadratic, the minimum is going to be the vertex, right? So we actually have the same minimum. We're going to say 0, -3, and again, it's for our graph. Axis of symmetry is the last thing we need to talk about, so get this down. Axis of symmetry is what you reflect about. The number you reflect over. Okay, so what do I mean? It's like what makes your mirror. So really quick, let's look at both of these. If we were to draw a mirror right in the middle of this graph, on this graph, the axis of symmetry would happen at x equals -1. So I'm going to say axis of symmetry, x equals -1. For this graph that we drew in our notes, the axis of symmetry is, we always have to use an x value. What does x equal here? X equals 0. So for our graph, the axis of symmetry is x equals 0 for our graph. Okay, let's look at quadratics from a table. So this one might be a little bit harder. If I were you, I would get this table in your notes as quickly as you possibly can. So really quick, draw the table. Given table of values for h of x, determine the key features. Okay, so we're going to go through, in the same way we looked at the graph, we're going to look at a completely different thing, a table. So the first thing we're going to look for is x-intercepts. X-intercepts, we made a note. For x-intercepts, y equals 0. So anytime you're trying to find x-intercepts from a table, you need to look where y equals 0. But I don't see y in this table, so where should I be looking? Always remember your function is y. So f of x is the same as y. H of x is the same as y. Your function is always going to be y. So for x-intercepts, we are looking for y equals 0. Here is where y equals 0. And here is where y equals 0. We have two x-intercepts for this graph, and we're going to write those 2 points. So we have 2, 0, and 4, 0. All right, cool. Let's go to the next one. Factors. Remember, factors, you're going to use your x's, and flip the sign. So for factors, we're going to use these x-intercepts and flip the sign. X minus 2, parentheses. Factors always have parentheses. And then we have x minus 4, because these were positive, right? So we just took those x-intercepts and flipped the sign. All right, y-intercepts. We took a note over here for y-intercepts, and we said x equals 0 for y-intercepts. So let's remind ourselves of that again, x equals 0. And let's look back at our table. Where does x equal 0? Here's x equals 0 right there. So our y-intercept is going to be 0, negative 8. It's that point. 0, negative 8. All right, we're almost done. Vertex. Okay, we described over here, we described the vertex as the point. The vertex is the point where you turn around. Right here, we talked about it's where you turn around. So we're going to look at the y values and see where they like start repeating. Where do the y values turn around again? So we go from 0, negative 8, negative 9, negative 8. Check it out. They turned around right here. Your y values flipped around at x equals 1. At x equals 1. So your graph might look something like this. Negative 9, negative 8. At x equals 1, you have negative 9. At 0, you have negative 8. At 2, you have negative 8. So your graph looks something like this. So we turned around at 1 at this point. 1, negative 9 is when we turned around. That's when we started repeating. Cool. All right, y'all, notes is a little bit longer today because it's review. So let's go ahead and go to the next part. We're almost done, though, I promise. Next part is graph this function. So go ahead and write down the instructions. Graph the function f of x equals x squared minus 3 equals 2x. Oh, this is the function. I don't like this. Here, sorry. Graph this function. Okay, cool. We don't need the f of x. That's all I was trying to say. X squared minus 3 equals 2x. Okay, first thing we're going to do, I have instructions over here. Steps. First thing, get to standard form. So remember, standard form is a x squared plus bx plus c. This is not in standard form right now. We need to move this 2 over. We need to move this 2 over. 2x. So we're going to subtract 2x from both sides. That way we have x squared minus 2x minus 3 equals 0. Cool. So now we are in standard form, right there. Next step is factor. Factor. So we're going to very quickly use the box to factor this. I'm going to do it right here. So really quick, let's factor. I need to multiply to negative 3 times 1, so negative 3. I need to add to negative 2. Numbers that multiply to negative 3 and add to negative 2, that'd be negative 3 and 1. All right, cool. And then I'm going to put x squared minus 3. Okay, and then we have x, 1, common x. These have negative 3 in common. Cool, so our factor form is x plus 1 and x minus 3. Okay, so now that we've factored, here's what we're going to do. We're going to graph. The first thing that we're going to graph is the roots, or the zeros, or the x-intercepts. So let's go ahead and find those. What does x equal? X equals, remember, flip the sign, negative 1 and positive 3. So we can put those on our graph. We can put those on our graph. -1, where x is, +3. We have now graphed the roots, the zeros, the x-intercepts. Cool. Now we're almost done. Use the equation for the vertex to find the vertex. So the equation for the vertex, let's write this down, vertex equation is -b/2a. That should sound a little bit familiar. That is from the quadratic formula. So to find your vertex, you're going to put -b/2a. So we need to go back to this form. -2 was b, a was 1. So -b/2a equals -2, because I have to plug in -2 for b, over a was 1. So 2 times 1 equals, sorry, my notes are a little messy today, my bad, 2/2, because this turns positive, right? Negative and a negative turn positive. So we have 2/2, which equals 1. Okay, so we have x, sorry, I should have wrote that before. X equals -b/2a. That's the x value. So let's go ahead and make sure we write x equals 1 here. X is 1. We need the y to know the point where the vertex happens. So we know the vertex happens at x equals 1, right? So I'm going to put my axis of symmetry there, because the axis of symmetry, the reflection always happens where the vertex is. But I need to plug that into my equation to find the y. I need to plug in x equals 1 to find the y. So we're going to take this equation, I'm going to do it down below, and we're going to plug in 1 for x. So we have, the equation that we have is x squared minus 2x minus 3. Let's plug in x equals 1. So we have 1 squared minus 2 times 1 minus 3. This is equal to y. Right now we're finding y. So this is 1 minus 2 minus 3, which equals -2 minus 3, that's -5, plus 1, this is +1, that's -4. So y equals -4. Now we have a point for the vertex. We have the point. Let me do that here. The vertex happens at 1, -4 for y. So let's go ahead and put that on the graph. 1, -4. Boom, there's our vertex. Okay, so now you know how to graph a quadratic after you factor it. As long as you can get to factor form, you can graph that function. Now, some of y'all have learned to graph with tables. I drew this on here just in case people wanted to use it to graph, but really what I wanted y'all to learn today was graphing from factored form. So that's why I have these steps that we went through, and we walked through those steps. If you wanted to find the y-intercept, let's just do that really quick. If you want to find the y-intercept, you would plug in x equals 0. So again, we have our equation right here, x squared minus 2x minus 3. So x squared minus 2x minus 3. If we want to find the y-intercept, we plug in x equals 0. Oops, minus 2 times 0. Minus 3. And this is always true. This is really important to know, y'all. Y-intercept, x equals 0. We're going to keep going back to that all year. Let's see. 0 squared is 0. -2 times 0, that's 0. So 0 minus 3, you start at 0, you take away 3, you get -3. So we plugged in, for the y-intercept, we plugged x equals 0. So if we were to write our point, here's the point. X equals 0, y is what we found here, equals -3. Check it out. 0, x is 0, -3. That is where we crossed the y-axis. Okay, that is our y-intercept. I'll label it. All right, so that was notes for today. I know it's kind of long. Now you are going to get a chance to practice. Good work. Good work writing all that down. If you need help, you can go back in your OneNote in the content library and you can find all of these notes in there.